All right, here we go, back again. We're going to talk more about the 5-number summary. We're going to go back in a box and whisker again, but this time we're going to look at outliers. We're going to go in a little bit more detail so you get a feel for what this box and whisker thing is. So suppose I went to the high school and all the kids, well, let's say the middle school, because high school, even though high schools do go trick-or-treating, let's say I went to the middle school and I said, how much candy, and I asked all the students, how much candy did you get on Halloween? 12 pieces. How much did you get? 9 pieces. How much did you get? And I wrote this down, the number of pieces of candy each student got on Halloween from trick-or-treating. Trick-or-treat, trick-or-treat. And I took that list down, and it was 1,000 kids in the school, something like that, okay? And I'm like, all right, so I got 1,000 values, all right? So I have a lot of data here. I put them in order from least to greatest, and the least amount of candy to the most amount of candy, and I went and found the middle, and I found the median, and I found that the very middle person had 29 pieces of candy. And then after I found that middle, I went to the median, that's called the median, the very middle. I went to the bottom half and found the median of that bottom half, and I found the median of the bottom half was 22 pieces of candy. And then I went to the median of the top half, which is called Q3, and 36 pieces of candy. The maximum person had 144 pieces of candy. They were out there for a while. Trick or treat, or you'd have the bullying people, give me your candy. Either way, they had a lot of candy, okay, this top person. And so let's see what we can look at this thing and see if we can make a little box and whisker plot out of it. All right, so things I can tell from this data. Remember, don't forget that 25% of the students in this school had 22 pieces of candy or less. Half the students had 29 pieces or less, which means half the students had 29 or more. Remember, if 25% had 22 or less, 75% of the students had more than 22. So think about that, what that means. 75%, 3 out of 4 kids that walked by had more than 22 pieces of candy. But only 25%, 1 in 4, had more than 36, because Q3 is always in the 75th percentile, meaning someone who had 36 pieces probably had more candy than 75% of the people, of the students. Okay, now, let's make a box and whisker plot. Let's look where the min here is 144 and the max is, the min here is 0. A lot of students get 0 because they don't trick or treat. The max here is 144. So let's try to make a box and whisker plot to have all that. And that max is, it could be, it looks like it's way out there. It's lying way out there. So maybe it's an outlier. Let's see. All right, here we go. Now, I need to plot this thing. I need to go from 0 to 144. So I'm just going to make my scale. And I'm going to go 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 20, 30, 40, let's go 50, let's go right, here's 50. So here's my scale, and I'm going to build a box and whisker plot on top of that scale, just using the 5-number summary. Here I go. 0, 22, 10, 22 is right about there, 29, 10, 20, 30, it's a little bit less, all right, 36, right between 30 and 40, maybe a little bit, and 144. All right. Q1, Q2, Q3, or Q1 median. And here we go. Okay. Now there's an interesting box and whisker plot. It's interesting because this guy seems really far away, and trying to get the feel for the box and whisker plot, it's a little bit difficult to get the feel for what this thing means. I'm going to show you a little trick in a minute on how to kind of transform any box and whisker plot into a histogram. You can't exactly do it, but to get an idea of what the underlying histogram will look like, it's called the fish tank method. We'll get to that in a minute. Now, let me look at this guy. All right, I need to figure out, this guy's definitely an outlier. It doesn't seem to go with the rest of the group. The real definition of an outlier is if it looks like an outlier, smells like an outlier, you pick it up, you're like, it tastes like an outlier. If it looks, if it seems like an outlier, it probably is. There's no real definition. But years ago, this guy, John Tukey, I think his name was Tukey. It's really named Tukey, huh? Tukey said, all right, let's find a way to find outliers. And this is what he came up with. Well, we have this distance of the box right here. And let's call it something. Well, we know it's a measure of spread. The more spread out the data is, the wider that box will be, the more condensed it is, it'll be in. So first, let's think, what can we call this thing? And we have one measure of spread that we learned in middle school. That measure of spread was called the range. Remember that one? High minus low is the range. So the range here would be 144 minus 0. The range is 144 pieces of candy. So what we're going to do is we're going to go inside and find the range between the quartiles. So I'm not going to find this range, I'm going to find this distance. So instead of this distance, 144 to 0, which is 144, I'm going to go in here and find the distance between here, 36 to 22. 36 minus 22, how far is that? It's 14. And you know what they call that? That range that's inside the quartiles? It's not out here in the ends, it's in the quartiles. It's called the interquartile range, also known as the IQR. Interquartile range is simply always the third quartile, the distance from the third quartile to the first quartile. Okay? Distance from the third to the first. That width is the spread of the inner 50% of the data. In this case, it's 14. So, visually, here's your outlier catcher. If you imagine, and now this is kind of hard to imagine, but I'm going to draw like a larger box and whisker plot. I'm going to erase this stuff up here. So imagine, this is candy on Halloween, we know all that. So what you can think of is this. If you're standing on this box, and what you can do is things that you can catch with a net, things that aren't outliers. So imagine if you're standing on this box, like right here. I'm standing here, and I'm going to reach out and catch all the data values. So you're standing right here. Here's a mini version. I'm standing right here. But your net is only 1.5 times the width of that raft you're standing on. You're trying to catch like fish. So instead of this wide, it's one of these. That width, remember, is the IQR. It's one of these plus another half of one. So add on a half of one. So this is like your net. Let's put a little okay. So you're going to reach out and try to get everything with that net. Anything that's outside, you can't reach with your net, we're going to say they're outliers. They're way out there. I can't catch them. They're just like floating fish. So here we go. I reach out with this net. It's about that wide. And I go, and anything in here, and anything in here, we'll consider those part. We're going to connect those with, we'll grab them and pull them in. So I might grab a fish right here and pull it in, a fish right here. But if there's a fish out here, that little fish is just going to float away. Let's draw them like that, little fish. I can't catch you, little fish. And suppose here's some data values here, a bunch of fish. I can reach out and go, I can only catch these fish. So I grab them and I pull them in. This little fishy over here floats away. So what we do is we connect only the fish we can catch to the box and whisker plot. And anything outside that, we consider outliers. We mark them with little stars, little dots. And that's why you see outliers that look like this. They're like just a couple points that are out there. They mark them with little stars, you know. So that's it. Basically, anything within 1.5 of these IQRs, 1.5, is close enough to not consider an outlier. Anything more than 1.5 of those IQRs we'll consider an outlier. Okay? So let's look at that mechanically from this data set. Now we don't have the actual data, so I can't tell if there are outliers. I cannot tell you how many, but we can just tell you if they exist. Now you can see from this little plot here, if this guy reaches up 1.5 of these, he's going to put a dot, like anything past there is an outlier, down 1.5. So you notice there's no values below that, but there is at least one value up here. So I'm pretty certain there's at least one outlier here. But let's do the calculation. Now this calculation is in your book and it's pretty confusing, but I want you to think what you're doing. You're standing at Q1, and you're going to go down 1.5 of those IQRs, meaning this is the IQR, 1.5 of them, you're going to reach down. You're going to call that a fence. It's not really a fence, but it's kind of like an idea fence. Anything beyond the fence, I can't catch. I'm going to stand at Q3, and I'm going to go up 1.5 IQRs, which is a net, and I'm going to put another little fence. And I'm going to see anything beyond that we're going to consider outliers, even though they might not be, but this is a rule of thumb, just for our thumb purposes. So let's make that calculation with the original data. Back here, pieces of candy. All right, well, I'm going to see where my fences are. I know the way to find my fences. To stand, first calculate the IQR, which in this case we got. The IQR is 14. So I need to go up 1.5 14s and down 1.5. So I'm just going to calculate 1.5 of those IQRs, which would be 1.5 14s. Well, I know 1 14 is 14. Half of 14 is 7. So 1.5 would be 14 plus 7, 21. 21 candies. 21. Okay? That's how long my net is. So I'm going to stand at Q3, and I'm going to go up 1.5 IQRs. Remember, 1.5 IQR is the length of my net. So I'm going to stand at Q3, right here. Stand at Q3, right there, 36. And I'm going to go up 1.5 IQRs, up 21. And what do I get to? 36, 46, 56, 57. As you can see here, 10, 20, 30, 40, 57 is like right around here. It's my first fence, my upper fence. Let's go find my lower fence. I'm going to stand at Q1. Q1, I'm going to stand at 22. Now I'm here. I'm going to stand at, Q1. I'm going to stand at Q1. I'm here, Q1. I'm going to go down 1.5 IQRs. I'm going to reach out 1.5 IQRs. Remember, that's the length of my net. This is my data catcher. So, stand here. Q1, 22. 22 minus 21. Woo! Wait a minute. 1. Look at that. When I go down 1.5 of these, it actually comes down right here. So, this minimum is a possible outlier. However, in this case, I doubt it actually is an outlier, because I bet you there's lots and lots of zeros. I bet you this is a bimodal distribution, because you have a lot of kids with 0, and then probably another hump of the kids who went trick-or-treating. You have the non-trick-or-treaters, well, let's all be here. Imagine if you made this a histogram, it would look like this. A bunch of zeros. Not to mean you're a 0 if you didn't go trick-or-treating. I mean, you just didn't get any candy. And then maybe some that went to a couple houses. Then you got the guy out here with his buddy. That's probably what the histogram looks like. So anyway, just think about this. You stand at Q1, you go down 1.5 IQRs. Anything past that we'll call an outlier. Stand at Q3, go up 1.5 IQRs. Anything past that, we'll consider an outlier. I don't think I have time right now to switch the box and whisker plot into a histogram to kind of think about it, but I'm going to do that next, okay? Here we go. Bye. I'm going to shut it off, and then I'll say here we go in a minute.